This is FRM Part 2, Book 1, Market Risk Measurement and Management, and the chapter on evolution of short-term rates and the shape of the term structure. Remember that picture of the term structure of interest rates. There's time on the horizontal axis and yield to maturity on the vertical axis. And really the term structure is trying to give us a sense of not only what interest rates are today, but what investors and bondholders more specifically expect those interest rates to do sometime in the future. Remember that during a growing economy, the most common shape of the yield curve is upward sloping. Lots of people think that a sign of recession is a downward sloping yield curve, and sometimes that's true and sometimes it's not. But what we're going to do today is we're going to start out with a flat yield curve, and then we're going to move to an upward sloping yield curve, and we're going to introduce volatility, and you'll see that in these learning objectives. And so unlike the previous two chapters where we had multiple action words that wanted us to calculate, we only have one of those here. So what we're going to do is we're going to explain the role of interest rate expectations. Boy, that sounds an awful lot like yield curve shape. We'll talk about a risk-neutral interest rate tree. We did lots and lots of really fun things with interest rate trees in the last couple of chapters. We'll introduce this concept of Jensen's inequality and how it is used to explain convexity. And then we'll talk about some regular stuff from the fixed income market, maturity yields and volatilities. And then we'll go ahead throughout the slide deck. We're going to calculate some prices of zero coupon bonds. All right, let's go back to the very beginning of our understanding of term structure of interest rates. There are three pictures. There's a flat one, there's an upward slope, and there's a downward sloping yield curve. So we have to ask ourselves the question, what causes these kinds of things? And let's take the left-hand picture first and work through just a quick example. If interest rates today are, let's say, 10%, and everyone expects them to stay 10%, and everyone expects spot rates and forward rates to be 10% in year 1 and year 2 and year 10 and year 50, well, then we're going to have a flat yield curve. However, if we know that interest rates today are 10%, but for some reason, maybe because of a growing economy, maybe because of an expectations that inflation is going to rise, maybe because currency values are going to change, whatever those reasons, let's suppose that we expect the rate to rise to 12 or 14% in 1 year. So you can borrow today at 10%, but if you wait until a year or 2 years, you'll have to pay that expected rate of 12% or 14% or whatever that number is. And that's going to be an upward sloping yield curve. So notice that second block point I have written there. Expectations among investors have a major bearing on the shape of the term structure. So that should make perfect sense. Now let's take a quick example here. And in the first part of the chapter, what the author assumes is that there is no uncertainty surrounding interest rates. So we know that the 1-year rate is 6% and forward rates in the future are going to be 6% over the next 2 years. All right, so what we can do is we can use that information to compute the price of a zero coupon bond. And notice there's a $1 in the numerator, so let's just pretend that this zero coupon bond matures for $1. The price of the 1 year and the 2 year and the 3 year are just those discounted values. So 94 cents and 89 cents and 86 cents. Of course, that should make perfect sense just from regular old time value of money stuff that we learned way back, maybe even in high school, right? So this is an example in which the yield curve is flat, and then investors are willing to pay lower prices for longer term maturity bonds because they're going to realize the effects of compounding. So that 3-year zero is only about 87 cents because you're going to get 6% and then 6% and then 6%. And the important part of the beginning of this chapter is that those 6% are guaranteed. Now, the interesting part of this is that, if you have a 3-year investment horizon, what you can do is you can just buy a series of consecutive 1-year 0 coupon bonds, or you can just buy a 3-year 0 coupon bond. And because we have this flat yield curve and because we've removed uncertainty, then however much you pay for those things over the course of 3 years, you're still going to have, well, whatever it is that you want in the future. Now let's go ahead and ask ourselves the following question. Let's suppose that the 1-year rate today is 6%, but we expect the rate in 1 year's time to be 8%, and then the 1-year rate in 2 years to be 10%. So notice we start with 6, and then we expect it to go up to 8, and then we expect it to go up to 10. So this is going to result in an upward sloping yield curve. But what we need to do here is try to figure out what that spot rate is going to be sometime in the future. So notice the second block point. The 2-year spot rate can be computed as, well, I have the answer there, 7%, but let's go ahead and calculate it. So the price of the 2-year 0 is going to be, well, what did we do back here? We did 1 over 1.06 times 1.06, but in this case, we're going to do 1 over 1.06 times 1.08, right? So we're going to get 87 instead of the 89, right? 87 cents instead of the 89 cents. And then what you can do is you can figure out kind of what is that 2-year spot rate. And so you just do a little algebra there, and it comes out to be 6995, which is about 7%. And then you can do the same thing with the 3-year rate, which turns out to be 7987. And so I rounded there, that's going to be around 8%. But notice that if we have this upward sloping yield curve, the price of the 2-year is 87 cents and the price of the 3-year is 79 cents compared to 89 and 86 cents, right? Which means then that those spot rates, which are 6% today, then they must be 7% and 8% in the next couple of years. So this is an upward sloping yield curve. And so remember what I said back here. Where was that? I guess it was here when I said, look, if you're an investor, you would be indifferent between buying those series of 1-year zeros versus the 3-year 0. And here that may or may not be the case, but the idea is that you're not willing to lock in a 6% rate for 3 years because there's that opportunity cost associated with the upward sloping yield curve. You would be foregoing the 7% and the 8%. So this is really important here. Interest rate expectations then, they will inform the shape, so the upward slope or the downward slope and the level of the term structure over short-term horizons. Now, we did a 3-year period right there, and maybe it's probably more appropriate to do, let's say, a 3-quarter period because those expectations can be much more, in fact, they are much more precise over shorter time periods. So notice the second block point. Investors have much less confidence in their expectations about spot rates several periods into the future. And of course, those of you who are parents and pretty much know what I'm talking about, you can predict with a relative certainty the behavior of your children today. Like when you send them off to school, they're going to go to school and they're going to sit with their friends and they're going to study and they're going to complain about the slow day and they're going to come home and they're not going to want to go outside and play sports. They're going to want to play on their video games or whatever it is. But if I said to you, predict what your child is going to do 4 years from now coming home from school, oh my gosh, who knows what that's going to be. So look at the last block point there. Expectations are unable to describe the shape of the term structure for longer term horizons. So we need to consider other factors like inflation or outcomes of future political elections or multiple factors. Now, the next section of this chapter introduces the concept of volatility. All right, so all we've been doing so far is saying, okay, we're basing our term structure of interest rates on the expectations, assuming that those expectations will be realized. But now what we're going to do is say, hey, you know what? We don't really know what interest rates are going to do. We have some expectations, and we know that those expectations are more reliable in the short term than they are in the long term. But we also know that even short-term expectations are not always as accurate as you would like them to be. Witness stock market crashes in 1929 and in 1987, and so on. So look at the picture there. We're going to go back to our interest rate path. We're going to start at time period 0 with our regular 6%, just like we've done before. But now we're going to say that we have a 50% chance of moving up to 8% and a 50% chance of moving down to 4%. And notice if you take the expectations, half of 8 and half of 4, you still get 6%. And then in time period 2, we'll go up to 10 and then all the way down to 2 as that tree has more and more branches. But notice the 6%, is kind of straight across the line there. So that's 6%. But there's uncertainty surrounding those expectations of 6%. And so note what I have there in bold there. This is an illustration example assuming volatility of 200 basis points. So the question then becomes, how can we use this interest rate tree, assuming this kind of volatility with these risk neutral probabilities of 50%? How can we compute the price of zero coupon bonds? That illustration on the left is exactly what I have in that previous slide. And then what we're going to do is we're going to find the 2-year discount factor, which is going to give us the present value and the price of that 2-year zero coupon bond. So what we'll do is we'll take 50% of the reciprocal of 1.08, we're doing the compounding there, and 1.04, and then discount that back at the current spot rate of 1.06, so we get 89.03. So if we are going to buy a 2-year zero coupon bond in the face of this type of uncertainty, we're willing to pay 89.03 for that. And let me just remind you that this is the process what we completed in the previous chapter of that backward induction, where we start at the end and then we move backwards. What we can do using the relationship between and among prices and rates is we can figure out what that 2-year spot rate is. And so let's just take that 89.03 and solve for, notice I have there on the right in the denominator R sub 2. That's going to be the 2-year spot rate. So if you do a little bit of mathematics, you get 59.81. And so you should be thinking, wait a minute, what did we just do back here? Let's go ahead and do this. What did we do? Back there, we computed the price of that 2-year zero as 89 cents. That was with certainty, and now with some uncertainty, that price is going to be 89.03, which then must mean if it's a higher price, then that spot rate has to be lower. So not 6%, it turns out to be 5.98 something percent. And that difference of the 1.8 basis points is going to be the difference in the prices with certainty and without certainty. And that can be summarized by the convexity at that point in the term structure. And this is really cool. Remember when we learned bond prices way back in the old days, we learned that there is not a linear relationship between yield and dollars, right? The yield to maturity and dollars of present value, there's no linear relationship. It's a curve, all right? So it goes like this. And I have a slide here in just a few minutes. So what we're trying to do is we're trying to look at the difference between certainty and uncertainty. and see that we get that 1.8 basis points. So we're trying to figure out what is the value of convexity. Remember that bondholders, they love convexity if they expect interest rates to fall, because then the bond price will rise by substantial amounts. Bondholders don't like convexity if they expect interest rates to rise, because then they'll lose substantial amounts. All right, so what we're trying to do here is figure out the effect of convexity. And this can be summarized using this concept called Jensen's inequality. So we have a challenge here. Demonstrate Jensen's inequality for that 2 years zero coupon bond with that face value. All right, so with all the previous interest rate expectations. So once again, there's our interest rate tree. And all we're going to do is some simple math here. We're going to take a look at the left-hand side of Jensen's inequality versus the right-hand side of Jensen's inequality. And at first glance, they look like they're an awful lot the same, but the expectations operator is moved around between the left and the right-hand side. Notice in the left-hand side of the inequality, the expectations operator is all the way outside of the brackets. So that's an expectation for 1 over 1 plus r, right? So that's that discount factor. But on the right-hand side, it's 1 over the expectations of 1 plus the interest rate, which is the expectations for the term structure. So we can quickly do the math here. Let's look at the left-hand side. So if we take half of the reciprocal of 108 and half of the reciprocal of 104, we get that 9437. And then if we look on the right-hand side of the inequality, we're taking half of the 1.08 and half of the 1.04, and we get 9434. So there's an application of Jensen's inequality. And of course, 9437 is greater than 9434. So let me summarize this for you. The left-hand side is equal to the price of that zero coupon bond today, which happens to be greater than the discounted terminal value, the discounted terminal cash flows at the 6%. But instead of 6%, we do the expectations of 6%, 50% of 1.08 and 50% of 1.04. Therefore, of course, that yield or that spot rate has to be lower. And that's what I have on this slide here. So let me just look at those, look at the right-hand wording. So the price of that zero coupon on the left side is 89.03, right? So there's the price. The right-hand side is calculated as the discounted terminal cash flows, which is only 8,900. All right, so this effectively demonstrates that the price of the 2 year zero is greater than the price obtained by discounting. That must mean then that the implied rate has to be lower than 6%. So here's that picture I was telling you about a little bit earlier. And of course, the standard kind of a presentation is to say, let's look at a 1 year bond and let's draw the relationship between yield and bond prices on the vertical axis. And a 1 year bond is almost a straight line. I mean, it looks like a straight line. It's almost a straight line. In fact, I have my undergraduate students do an assignment in Excel where I make them draw a 1 year bond and then a 20 or 30 year bond. And boy, you can, it almost looks like a line, but it's not quite a line. But then the 30-year bond in red, that has convexity. Clearly, the slope of that 30-year bond changes from 2% all the way out to, what is that far one? 8%. So look at the first circle point I have there. The implication is that as the maturity of the bond increases from 1 to 5 to 10 to 30, the price-yield relationship becomes more convex. And the cool thing about what we've done so far today is that that value of convexity increases with volatility. And so how do we measure volatility in our simple examples here so far? What did we do? We started with the 6 and then we went up to 8 and down to 4. If we work through an example where we went up to 10 and down to 2, then the difference between those upper and lower nodes that must mean that convexity is going to increase. And so that, what did we come up with just a few slides ago? Those 1.8 basis points, that would widen. Now, how about if we include a conversation on risk-averse investors as opposed to the risk-neutral investors that we've been examining up to this point? And remember, the risk-neutral investors are those investors who really only care about compensation. They're really not measuring risk or quantifying risk or considering risk. They know it exists, but they don't really worry about it. A risk-averse investor, however, is an individual who says, look, if you are going to force me to take this much extra risk, then I'm going to demand, well, whatever it is, either this much or this much extra return. All right, so there is our interest rate tree. And let's go ahead and compute the price of a 2-year zero coupon bond for a risk-neutral investor, 89.03. Can we already do that? However, let's go ahead and suppose now that the return can be either the 4 or the 8%. And a risk-averse investor is going to demand a risk premium for exposing him or herself to this extra volatility or this extra uncertainty. And so we're going to come up with the price of 88. So what did we have before? We had the 89, which we've done before for the risk-neutral investor. But now, and this is the more interesting part of this chapter, I think, we're going to show that price is only, what does that turn out to be? 88.78. So what does this say? Of course, a risk-averse investor is going to be willing to pay less for that zero coupon bond. And that takes us through the evolution.